Hello friends, I'm Kushal back again from Indeed Inspiring. So we are going to discuss about Big Data Hadoop. This is an introductory section. The agenda would be, we will be discussing about big data, the factors of big data, the challenges and opportunities we can have with big data, approaches as a solution, the vertical approach and horizontal approach. We will discuss the concept of distributed computing, and then a solution, that is Apache Hadoop, and certain popular use cases. So big data, you must have been hearing this term from long, that we have been facing big data challenges, or companies are generating or applications are generating so much of data. I have written here that big data is a challenge and it is an opportunity. So I'll explain you how it can be a challenge as well as it can be an opportunity. This is a definition given by Gartner. It says that big data is a term applied to data sets whose size is beyond the ability of commonly used software tools to capture, manage, and process the data within a tolerable elapsed time. If you divide this particular definition into small phrases, then it is easy to understand that big data is a terminology which is applied to data sets whose size is beyond the ability of commonly used software tools to capture, manage, and process. Okay, so the available infrastructure which we have, it is incapable of capturing, managing, and processing the data. Okay, and second part is, even if we are able to capture and manage the data, we are not able to process the data within the given timeline. That is the biggest challenge. Okay, so storage is one problem, another problem is processing, and processing within the given timeline is a big challenge. As per the predictions, there will be more data growth, around 800% data will be growing in the upcoming years, as well as 80 to 90% of this data is unstructured. This is another challenge. Okay, now let's move into the next slide. So here, if you can see that we have different formats of data. Data can be present in the form of structured format, unstructured format, or semi-structured format. Okay, so the currently available software tools, they are basically able to handle structured data in a best possible manner. Unstructured and semi-structured data, they are basically complex data, so therefore the current softwares are they are incapable of properly handling this particular data. Second challenge is, if we have 100 TB of storage and every day there is 10 terabytes of data being produced, in that case we will not be able to capture and store that 10 TB of everyday data for more than a period of 6 or 7 days. Every 6th day we'll have to wipe out the data of the first day. Okay, this is another challenge. These are certain statistics given by different magazines, so you can just have a look that how much digital data we have been facing, we have been seeing. So here you can see the big data analytics market is set to reach $103 billion by 2023. In 2019, the big data market is expected to grow by 20%. 2020, every person will generate about 1.7 megabytes in just a second. Internet users generate about 2.5 quintillion bytes of data each day. As of September 2019, there are 2.45 billion active Facebook users. 97.2% of the organizations are investing in big data and artificial intelligence. Using big data, Netflix saves $1 billion per year on customer retention. So these are certain more statistics, recent ones. This chart, you can see that it was observed that in 2009 it was around 800,000 petabytes of data, and in 2020 the estimation given was 35 zettabytes of data, but now we see that there is near about 40 zettabytes of data in 2020. So the forecast which was being given, okay, so that has come true, and more than that we are having data today. This is the chart from where you can have a reference from gigabyte to terabyte, then to petabyte, then exabyte, zettabyte, and yottabyte. So zettabyte lies here, and here you can have a comparison. 1 zettabyte is equal to this much amount of GB. So you can just imagine that how much data are we having today. Let's discuss about the big data factors. Volume, velocity, and variety. These were the three terms coined which actually contribute to make data as big data. Volume is data which is stored in the servers. So there can be data centers, there can be servers where data is stored. It can be data of a software, it can be data of a survey, any kind of data which is there stored in the servers. Second is velocity. So this is the data which is being produced at this particular point of time. Okay, so let's say some data is being produced at this particular time that will be called as streaming data. Example, you go to ATM, you make a transaction, so data is generated. You click some pictures, data is generated. You are standing in a traffic signal and there are cameras, data is being generated. You are visiting a hospital, there are sensors and cameras, data is generated. So that is streaming data, the live data which is being growing, which is being generated. Then variety, there are different types of data. We have videos, images, okay, text, which is unstructured data. We have some HTML kind of data, XMLs, JSON format, which is called as semi-structured data. Logs is also semi-structured data. And we have structured data. Structured data is like data which is in the form of tables. The simplest example could be MS Excel. Okay, so Excel is basically it has got rows and columns, so that is basically example of structured data. Other examples could be any database softwares which make use of SQL, structured query language. They are also example of structured data. So these are the additional V's of big data: value, veracity, and variability. Value means more the data you have, better the analysis you can do, or we can say precise will be the result. If there are two parties, party A and party B, 50 people support for party A and another 50 people they support for party B. In this case, if all of them will participate in the voting mechanism, we will have data of all the 100 people and there will be a tie. But let's say only 80 people participated for the vote, and out of these 80, 30 are the supporters of party B and 50 are the supporters of party A. So party A is going to win. In actual, we know the results are wrong because there are equal number of majority which are supporting both the parties. So if we could have collected more data, we could have analyzed the real situation and the results would have been correct. Veracity means ambiguity in the data. So here, if we have the data, but we are not able to process the whole data due to lack of algorithms, softwares, or infrastructure. In this case, we may process a part of data or a sample of data. Let's say we have a survey data of 1 million users and we are just analyzing survey data of around 1000 people. So in this case, we will derive some results, but we are not very sure that these results are actual on the basis of 1 million users, because apart from those 1000 records, other users may have different pattern, different feedback. Okay, so this is called as ambiguity or veracity. Next is variability. It means where all big data analytics can be used. So once you analyze the data, it can be used, or the results of the analytics can be used in multiple domains. So that is called as variability of the data. These are the 6 factors which make data as big data. Let us now discuss about the challenges of big data. This is a simple example. Let's say you own a sports accessories and product store. This is a physical store located in your local area. You are running this business for quite a number of years. Once you started to sell these products, obviously your family, your friends must have helped you, but sooner or later you would like to encourage or you would like to promote your business to the local people so that they can come and they can buy your services and products. Now let's say somebody came to you and he was your friend. He said that I can help you with online selling as well, and that person helped you creating a website. So when he created a website, then apart from selling from the local store, you have started selling the products from online portal as well. So once you started to sell, your sales were increased. Let's say there was another guy who helped you for digital marketing also. So he promoted online, and now there is more online sale, as well as the physical store is also going well. But if you want to analyze that how is the progress, how is the turnover going, then you will have to make use of analysis. In this case, we have a tool called as data warehouse. So you can make use of data warehouse in this case, and data warehouse can help you to analyze all your sales and purchases data. With the help of one tool which is called as ETL, you can take all your data from your web portal's database into the data mart. Once the data is inside the data mart, okay, then you can process it, and after processing you will get a result like this, that first year it was around 1 CR of turnover, second year it was 3 CR of turnover, and it was kept on increasing. If you see the pattern, 9th year it was 18 CR of the turnover, and 10th year it was down to 12 CR. So from first year till 9th year it was growing, but in the 10th year it was a loss basically. So now the kind of analysis we have here is, we call it as, it answers the question what. But if I basically try to ask you why has it happened, so the limited data available in this slide will not be able to answer why there is a loss of around 4 CR this year. Okay, so this is a kind of graph that it was increasing and then basically it was down. Now if you want to basically analyze why there is a loss, in that case you will have to analyze the customer's data, your vendor's data, and that you will get from your call centers whenever your teams are communicating to your customers, to your vendors, whether they are satisfied to your products or not, whether your vendors are satisfied or not. You'll have to check the emails, you'll have to check the reviews and ratings on the websites and social media. You'll also have to see the branding, promotions and marketing activity going on. So all this data will tell you why that has happened. But if you understand, this data is not in the form of a table or structured. This is unstructured or semi-structured data. Call center, email, reviews, all unstructured. Only ratings is structured. So this data, if you try to load it into the same tool, that is data warehouse, your ETL tool is incapable of handling this type of data. ETL's work is to extract the data and transform it and put it into the data warehouse, load it into the data warehouse. But here transformation is not possible for the ETL, because ETL can transform only structured data. So therefore we have some set of tools which are working parallel to the ETL tools, and they are called as ELT. So what we do is extract and load it, and transformation part we take care afterwards. So this kind of infrastructure or set of tools you will require, where ETL tools can fetch all this data and store it into a system. Here we have a system which is called as HDFS, which is a part of Apache Hadoop. We call it as Hadoop Distributed File System, which will allow this kind of data to be stored. And MapReduce is a technique of Hadoop which will allow to process over this data. And this will give the answer of why has it happened. So now I believe you understand what is the challenge. The challenge is basically we have a lot of unstructured data, and that data cannot be handled by traditional tools like data warehouse. So we need something new like Apache Hadoop. Certain more statistics of the challenge: 75% of the current data warehouses, they are not able to scale up to the new velocity and complexity of the data demands. 86% of the companies cannot deliver the right information at right time. There is a law called as Moore's law. It says that the number of transistors on the ICs, integrated circuits, they keep on doubling every 2 years. But there is a saturation point. It cannot happen always, right? So this is a time where we are facing a saturation limit to this also. Next could be nanotechnology, but nanotechnology is not affordable by all the companies as in terms of cost is concerned. Another thing you can see here, we have around 6 GB of hard disk, we have 32 GB of RAM capacity, we have core, we have i7 processors. This is the current capacity we have, but this is not capable enough of handling the kind of data requirements we have today. Let us discuss about solutions. So we have two solutions, one is vertical approach, another is horizontal approach. We will discuss one by one. In these diagrams you can see both the approaches. Vertical approach says bigger capacity computers with time. So if you have a small infrastructure, you can replace the whole of the infrastructure with a bigger capacity infrastructure. And then whenever you have more demand, you can replace that with some other infrastructure. If you see that this is very expensive because you are replacing all of your existing infrastructure with a new one. Hardware is expensive as well as software is also expensive. Software has got licensing fees and that has to be renewed every year. Another challenge here is platform lock-in. If you are using Oracle software and then you want to have a IBM software integrated, then you will see that Oracle softwares will have more compatibility instead of Oracle and IBM softwares. Okay, so this is basically platform lock-in. Another solution we have is horizontal approach. Here basically we are focusing on if we have limited infrastructure and if we want to increase it, so we will add a required number of servers to the existing infrastructure. So this is scalable approach. Okay, so whenever you require some more number of resources, you add up certain machines, and whenever you don't require, you can easily remove them gracefully. Use of open source software will reduce the cost of the software as well. Use of Intel AMD hardware commodity machines will reduce the cost of hardware expenses also. So cost wise also this solution will be lesser expensive as compared to the scale up parameters or the vertical approach. Platform independence is available in case of open source software because they are not made intentionally for a particular set of tools. Different communities work for the open source softwares, so they are compatible with most of the available infrastructure. So these are the two approaches, and here you can yourself identify that the horizontal approach is better because as per the requirement we are increasing the number of servers, and as per the requirement we are decreasing the number of servers. And this approach actually falls under distributed computing. Distributed computing is a field of science, computer science, that studies distributed systems. So here you will have n number of machines, and these n number of machines are connected through a network, and they have a software framework which helps them to pass messages and work together for a common objective. So in our case, we would like to have a solution which can basically store a lot of data as well as it can process all that data. So a number of machines will be working together to store as well as process data in our case. Let's understand what is the power of distributed computing. If I need to process 100 terabytes of data and I have only one machine, one node, with a scanning speed of 50 MB per second, it will take 23 days to process 100 terabytes of data. But if I do the same thing with 1000 node cluster, it will take only 33 minutes. So you can see the huge difference from 23 days to 33 minutes. Obviously, we will face some challenge related to hardware as well as how to process and combine the data from multiple disks. But we will also discuss how our solution gracefully handles these challenges also. Apache Hadoop came as one single shot solution at one time, which gave these two solutions of storing the data as well as processing the data. This is a definition of Hadoop, which says that it is an open source framework for storing, processing, and analyzing massive amounts of multi-structured data in a distributed environment. As I said, it gives two solutions, one for data processing, which is known as MapReduce. It is a distributed data processing mechanism. The another solution is Hadoop distributed file system, which is a distributed data storage system. A brief history of Apache Hadoop. In 2002, Apache Nuts project was running. It was headed by the person called as Doug Cutting, and they were also working on Apache Lucene, which is a search engine library. Apache Nuts is itself a search engine project. They used a concept of Google, that is GFS, Google File System, or Google Distributed File System, in 2003, and they implemented into Nuts and it became Nuts Distributed File System in 2004. They also took help of Google for a concept called as MapReduce, which is a way of processing data, and they implemented it on Nuts Distributed File System, and the data was stored into NDFS, and the processing mechanism in Nuts was MapReduce. In 2006, it was renamed to Hadoop. It was renamed to Hadoop in the name of a toy elephant, which was played by the son of duck cutting, and the kid was used to call that elephant as Hadoop, and therefore the name it got as Hadoop. Then 2008, it became a top level project in Apache. It became open source, and it also broke the world record to sort terabytes of data. This is the brief architecture. If you see, I have written the architecture in two ways. This is Hadoop 1's architecture. Now we have Hadoop 1, Hadoop 2, and Hadoop 3. So quickly you can just see that it follows master slave architecture. Master has got name node, secondary name node, job tracker. Now instead of job tracker, we have resource manager in Hadoop 2. Slave, we have data node and task tracker. Now we have, instead of task tracker, we have node manager in Hadoop. There is a client library also. As per the solution, data storage, name node, secondary name node, data node, they are responsible for storage of the data. Processing, the job tracker and task tracker, or you can say resource manager and node manager are responsible for processing the data or managing the resources. Popular use cases, Amazon, they use political rallies, news and media. So all of these people, organizations, industries, they actually make use of big data to analyze it and to come up with some results and use those results. This was a popular show, Satyamev Jayate. They were actually processing 40,000 tweets every 90 minutes of the show, and it was a project taken by Persistent Systems, another example of big data. Thanks a lot. Keep watching our videos and also give your feedbacks.
If you liked our video and would like to recommend it to your friends, please like, share and subscribe to Indeed Inspiring Infotech. We would also love to hear your suggestions and feedback in the comment section below.